How does the wake of an object upstream affect an airfoil's aerodynamics? That's what we're here to find out today. So we have some simulations here. First of all, we have a simulation of a NACA 2412 airfoil. And this is important because it means it's cambered, which means it's producing lift at a 0 degrees angle of attack. And we have it installed at a 0 degrees angle of attack. And first of all, we have it without any upstream interference. So we can see what the flow looks like. We have the vorticity and the velocity. So we can see it's very well behaved in terms of the flow physics. There's no real craziness going on. Let's look at what happens when you put an object upstream. And now we have the object upstream. It's a cow directly upstream, so it's only like a few centimeters away from the leading edge. And the wake of the cow is now impacting the airfoil. And we have the Y plane and the Z plane clipped to show pretty much just the entire wake. And we can see that the wake is far less well behaved than the wake without any upstream interference, so no cow ahead of it. And we can see that because there's like this periodic like wobbliness going on. It's kind of shedding, like sort of the vortices shed from the cow are impacting the airfoil, but I don't think the airfoil is creating a volcano street itself. It's mainly coming from that wake from the cow itself. These are the exact same planes, just with the vorticity now. And you can see there is a lot of vorticity of all different little pockets. So it's not like just one coherent structure. There's a bunch of little things going on. And then the breakdown as well means that they're interacting and they're breaking down into very small vortices themselves. So the cow, I think, is producing most of the initial vorticity, which is then sort of inducing more vorticity off of the airfoil surface itself. And now we have just these Y plane, and we're looking at it from a little bit underneath, a bit down now. So we can see the wake of the cow and how that's affecting the airfoil. So this is interesting because the wake of the cow, you can see it's really only coming from around its legs, which means that the wake coming from the upper body is kind of being suppressed a little bit because the airfoil behind it has air going over it and accelerating itself. So that wake that would usually be there behind the cow is kind of being taken up by this faster moving flow to begin with. However, that doesn't mean that there's no wake. It just means that the wake is far less familiar than the typical cow wake that we're all familiar with. Now, the wake from underneath from the cow, that's obviously impacting the airfoil periodically because you can see that they're moving in synchronization. When the one underneath is wobbling from the cow, the blue bit underneath the airfoil is also wobbling in motion in time as well. So they're uniquely, inherently coupled, it looks like. And now we have two X-planes. I did one just behind the cow and fairly downstream of the leading edge of the airfoil. And the reason I wanted to do this is because I wanted to see what the structures coming off the cow, how they were mapping to the structures around the airfoil. And we can see that there is a coherence here where when the frequency of the shedding upstream or the wake upstream matches the frequency of the movement downstream. So they're obviously they're affecting here. Upstream wake is affecting the downstream wake along the airfoil. So that's it in the simulation. Make sure to like, subscribe. And if you want to get better at CFD yourself, check out the courses we have in the link in the description. And I'll see you in the next simulation. Peace out, amigos.